Hello, my name is THURGADARSHNE and my metric number is 193480. So today my group will be presenting on cockroft-walton multiplier circuit, which is also known as voltage multiplier circuit. So my part will be on explaining on the abstract and also experimental setup. So abstract is basically about the overview of the whole experiment. So I'll give a rough picture of how the experiment is conducted in this section. So let me begin. As you know, just now I have mentioned that cockroft-walton is a voltage multiplier circuit, and then as the number of stages increases in the circuit, the output voltage will also increase. So since there were limitations of wires in our lab, so when we conducted our lab, we could only proceed up to 5 stages. So which means only output voltage from 5 different stages were recorded and verified. After the lab was conducted, we did a simulation to verify our results. So the results obtained were verified and the lab was a successful one. So here, let me go to the slides here. Basically, this circuit converts AC to DC using a network of diode and capacitor. Later on, I'll explain more onto the diode and capacitor in the experimental setup. And multipliers were made out of 5 stages. And when the number of stages increase, the output voltage increases. So this is all about the overview of our experiment.
Let's get into what a high voltage multiplier, or also known as cockcroft DC high voltage multiplier, is. Basically, it is a device used to step up low DC voltage. It was first invented by John Cockcroft and Ernest Walton to obtain high energy from high voltage to power their particle accelerator to penetrate through the nucleus of a particle, performing the first ever artificial nuclear disintegration in the history. It is widely used in X-ray machines, particle accelerators, and microwave ovens. The advantages of cockcroft-walton high voltage multiplier over transformers are they are lower in cost, easier to isolate, and lighter in weight. So, this is the circuit of a high voltage multiplier. It is made out of a ladder network of capacitors and diodes. Basically, every time when the input voltage Vi changes polarity, the stacking up effect of charged capacitors through the diodes will increase the voltage by a factor of the multiplier. For our experiments, we have 5 stages, so the voltage was increased by 5 times. This is how the circuit works. When input voltage reaches its negative peak, negative BP, current flows through D1, which is currently forward biased, to charge C1 to a level of BP. When input voltage changes polarity and reaches its positive peak, positive BP, 2 VP is produced on C1. But since D1 is reverse biased at the moment, so current flows from C1 through D2 to charge C2 to a level of 2 VP. When input voltage changes polarity, current flows from C2 through D3 to charge C3 to a level of C3. Again, the input voltage changes polarity, then the current flows through D4 to charge C4 to a level of 2 VP. It is the cycle of charging up the capacitors that are giving the increasing voltage.
So now I will be explaining more onto the experimental setup. So as you can see in this slide, this is how the connection was done in the lab. So later on we will include a close-up video so that you can have a proper view of how we connected from the source to all the stages as can be seen in this picture. So now it will be just a figurative explanation. So AC source will be given from this machine, and then connected to each stage, and then there will be diode and capacitors in between the stages. So the function will be explained later. And in each stage, a multimeter will be used to measure the output voltage. So we could see an increase in voltage in each stage here. So there are oscillating and smoothening capacitors in this circuit. Oscillating column capacitors are charged in half cycle by upward odd numbered diodes. So there are odd numbered and even numbered diodes labeled here. So in the odd numbered diodes, they will be charged in half cycle. In the next half cycle, smoothing column capacitors will be charged by even numbered diodes. So in steady state, in no load condition, every capacitor acts as a smoothing column where it is charged to the maximum voltage. The maximum output voltage is 2nV max, where n refers to the number of stages. So since we have 5 stages, n will be equals to 5. So this is all about the experimental setup. Later on, there will be a video included into the experimental setup.
Okay, so basically my part is to explain about the simulation circuit. So this is a hand draw of 5-stage multiplier circuit. So these components we have consist of the capacitors, the diodes. So these are the apparatus that we use frequently, like diode. We need to know whether it's a forward bias or reverse bias. So there are total of 10 numbers of diodes and also as the capacitor. Next, so this is followed by we are using the project software to propose our circuit. So since we are using a V sine wave is an alternating current, so you will observe that most of the capacitor here are having the same value, so which means they are identical capacitors, whereby the diode are actually they are inverse, means forward bias and reverse bias to each other. So this is the full circuit of 5-stage multiplier. So this is the first stage of the multiplier. You will see that there are 2 diodes that are actually in a clockwise direction, or can be said that they are forward biased to one and another. But for capacitor, they are against to each other. So this is in reverse bias, whereas this is in the forward bias to the C1. Okay, so whereas this stage increases by stage. So this is stage 1, whereas this is the stage 2. Is the similar items to, because this is just additional of stage, and this is the second stage. We make up of second capacitor and the fourth capacitor, right? So next, we will see this is the third stage. It's a similar thing, just additional as I said. So next will be the stage 4. All right, so now we move on to the last stage, is a stage 5. The component used is capacitors, diodes, AC power supply only. So this is a classical stage of voltage multiplier because we have involved of multiple stage. So in short, the explanation is the diode V1 is reversed to C1 and forward bias diode towards the C2 or vice versa. So when the alternating current flow through the circuit, the capacitor is assumed that is initially uncharged and being charged through the forward bias diode over a period of time. So the voltage is being generated stage by stage so that this can produce a higher DC voltage or a current. So in conclusion, as the number of stages increases, the enhanced voltage will also increases too. Thank you.
Hi. Okay, so my name is AIFNI Binti GHOZI. My metric number is 193481. So for the result, the input that we decided to give during our experiment was 10 volt. The formula to calculate the output voltage is Vout equals to N VPP. VPP means voltage peak to peak. So basically the answer theoretically is for voltage, for output voltage is at stage 1 we supposed to have 10 volt, stage 2 20 volt, stage 3 30 volt, stage 4 40 volt, and finally stage 5 is 50 volt. That is for theoretical values. For the measured output voltage, we got at stage 1 we have the 10.3 volt, stage 2 is 19.2 volt, stage 3 is 30.8 volt, stage 4 is 42.2 volt, and stage 5 is 52.6 volt. As you can see, the theoretical value and also the measured value are not exactly the same, but it's quite similar. And from this, it shows that as the number of stage increases, the output voltage also increases. Okay, that's all from me. Thank you.
This is our cockroft-walton high voltage multiplier. We have assembled and connected this circuit together, and you can see the circuit here.
Now I'll explain about the connection of the wires in the circuit. This is the positive and negative terminal. This is stage 1, stage 2, stage 3, stage 4, and stage 5. Each stage has one diode and one capacitor connected.
So basically, we need to know on how to measure the voltage. Okay, so this is the 5 multiple levels. So we first measure for the first level. First level, the voltage will be first level, second level, third level, fourth level, and the fifth level, so that we get the output voltage.
Okay, so as you can see, we have inserted the AC voltage to 10 volt, and then the output will be in DC voltage. So the result that we obtain in each stage, which is 5 stage, is in the first stage we have 10.3 volt, and then as you increase the stage, it is theoretically it should be double. So for example, like this 10.3, if you times by 2, and then it will be 20. So this is 90.2, which is acceptable, and then double again, and then we get 30.8, and then 40.2, 52.6. That is our result.